Hello, today we are going to identify factors of a number and make square arrays. The first thing I want you to do is take 12 blocks or counters and make as many arrays as you can. Once you make your array, I want you to figure out what the different multiplication facts would be. I'll start one for you. I know that if I had 12 counters, I can make a 3 by 4. So I would use 12 total blocks, and I'd make a rectangular array that's a 3 by 4. My multiplication equation would be 3 times 4 equals 12. Notice when I'm using this grid, I'm circling each individual box. I'm not drawing lines around. I want to show that each different dot is considered a block. So take a couple of moments to figure out how many different arrays you can make for 12 total blocks. Here are the different options. So if we have one row of 12, we'd have a 1 by 12, and that would be 12 total blocks. The turnaround fact would be 12 times 1, and that equals 12. Then we can have a 2 by 6, because there's 2 rows of 6, and that would give us 12. Or the turnaround fact, 6 times 2, which equals 12. We could also have a 3 by 4, or 3 rows of 4, which would give us 12, or 4 times 3. And notice again, I circled or highlighted each individual dot to show us the 6 different combinations. This is what it would look like with different squares. So notice there's 2 squares by 6 squares, 6 squares by 2, 12 by 1, 1 by 12, 4 by 3, and 3 by 4. 1, 2, 3, 4, 6, and 12 are all factors of the number 12. Factors are numbers you get when you multiply 2 numbers together to get a bigger number. So they're numbers you multiply together to get another number. I like to think about it as factors few, because a given number only has a certain number of factors. So there could be a lot. You could have 8 factors for a number, 20, 12, even 100. But there's only a certain number of factors. You can't create ways to multiply to that number without it already being 2 whole numbers that would multiply to get you there. So if we're thinking about the factors of 12, the factors of 20, we have 1 and 20. I always like to start with our smallest number and our biggest, 1 and the number itself, and work my way in between. 20 is even, so 2 times 10 is 20, and then 4 and 5. So the factors of 20 are 1, 2, 4, 5, 10, and 20. The factors of the number 16, let's start with 1 and 16. Since 16 is even, it would be 2 and 8. And then our last factor is 4, because 4 times 4 is 16. Now I want you to take those counters again. I want you to take the counters and see if you can make a rectangular array with an equal number of rows and columns for the following numbers. So first start with 4 counters. Can you make an array that would be a square array where the number of rows is the same as the number of columns? Now try with 6 and then with 9. Which of those would make a square array and which would not? Let's see. If you have 4 blocks, you can make a 2 by 2. A 2 by 2 is a perfect square. If you have 6 blocks, you could do a 3 by 2 or a 2 by 3. That is not a perfect square. If you have 9, you could do a 3 by 3. which is also a square. So that does make a square array. So the number 4 and 9 are different than the number 6. So if you have 1 times 1, that makes a square array. 2 times 2 makes a square array. 3 times 3 makes a square array. 4 times 4 makes a square array. The number 1, 4, 9, 16, they're all a special kind of number because they make a square array. These numbers are called square numbers. Any number multiplied by itself is a square number. For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. The answer of a square number is called a square product. Why might these numbers be called square numbers? They make a square array. So our numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100 are all square numbers because 1 times 1 makes 1, 2 times 2, 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and you can go on. What kind of patterns do you notice about these square numbers? Well, first, I noticed that the difference between the square numbers goes up by 2. They're odd numbers that are plus 2. So between 1 and 4 was 3. Then it was 5 more, 7 more, 9 more. I'm also noticing that it goes odd, even, odd, even, odd, even, odd, even, odd, even. And the next one would be odd. So a square array is a special rectangular array that has the same number of rows and columns. So the number 1 would make a square array. 2 would not. 3 would not. 4 would. 5 would not. So if you could take that total number of blocks and make an array that's a square, it's a square number. Here's some examples. Here, the number 1 would make a perfect square. Same with 4, same with 9 because it's a 3 by 3. A 4 by 4 would have the square number 16. Let's see if we can figure out all the square numbers through 100. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. What would be the next square number? 6 times 6 is 36. 7 times 7 is 49. Our next one would be 8 times 8. What would our next one be? Our next one, 8 times 8, would be 64. 9 times 9 is 81. And our last square number is 10 times 10. Our last square number through 100 would be 100. So we spoke a little bit before about how square numbers go in a pattern odd, even, and we get them by multiplying a number by itself. One last thing you'll notice is on a multiplication chart, our square numbers actually make the perfect diagonal because 3 times 3, when they match together, they make 9. 4 times 4, 5 times 5, 6 times 6, 7 times 7, and on. So a square number is called a square number because it makes a perfect square array. A square number occurs when a number or a factor times itself are multiplied. So for example, 10 times 10, where we have the same factor twice, would give us 100, which is our square number.